Next topic is function na. Okay, see, now actually definition of function is a rule from a non-empty set A to another non-empty set B that associate each member of A to a unique member of B. Actually this one is only we have to remember. Condition to become a function is each member of A is associated with a unique member of B. Unique, it means only one, not other than anyone. Okay na, unique, only one. So I am writing first. Okay, then we will take some example. Function is a rule from a non-empty set A to a non-empty set B that associate each member of A to a unique member of B. Okay, so function is a rule from a non-empty set A to another non-empty set B that associates each member of A to a unique member of B. Okay, now I am taking example. Now we have to identify that which one is the function or not. Okay, before this one, symbolically you can write this one as, see, symbolically write as f a to b. Okay, symbolically you can write this one as f a to b, and we read it as f is a function from a to b. Okay, how to read this one? F is a function from a to b. Okay, now I am taking example. See, suppose this is set A and this is set B. This is set A and this is set B. Okay, I am taking total 4 varieties, A and B, A and B. 1, 2, 3, 4, A, B, C, D. 1, 2, 3, 4, A, B, C, D. 1, 2, 3, 4, A, B, C, D. 1, 2, 3, 4. Okay. Now I am taking some connection. Then we have to identify that which one is the function. I am associating A with 1, B with 2, C with 3, and D with 4. A with 1, B with 1, C with 1, and D also with 1. A with 1, B with 2, C with 3, there is no connection for D. Okay, A with 1, B with 2, C with 3 and 4 both, and D is also with 4. Okay, now suppose I am taking some connection for A to B. Now we have to identify which one is the function and which one is not a function. Okay, by checking the definition. So see, for this one, function is a rule from a non-empty set A to non-empty set B that associate each member of A to a unique member of B. Unique, it means only one and only one. Okay, so see, here each member is associated, that is clear. Now check that these members are associated with unique member of B or not. A is associated with 1, B is associated with 2, C with 3, D with 4. Unique na? Okay. So this one is function. Now in this one, again, condition to become a function is each member of A must be associated with a unique member of B. So first thing, each member is associated. There is no pendency na? Okay. And A is associated with 1. B is associated with 2, B associated with 1, C also with 1, and D also with 1. For these all, 1 is unique. Okay na? For these all, one is unique, so this one is also a function. It means actually I am taking this one to explain one thing. You may connect 2x with 1y, but you can't connect 1x with 2y. Okay na? See, like this one, suppose y equals to sin x, definitely sin x is a trigonometric function. Now it is not possible na, that sometimes we are putting x equals to pi by 2 and sin pi by 2 is always equals to 1. It is not possible that one day I am getting 1 and other day I am getting minus 1, that is not possible na. So for any one x you can get only 1 and 1y, unique value of y. Okay, these are x and these are y, like this one. Now see, in this one, to become a function, condition is each member of A associated with a unique member of B. Here each member is not associated. There is no connection for D. Okay, so each member must be associated. Now, if you have any element A which is not associated with any element of B, then this one is not a function. Okay, in this one each member is associated, but actually C is associated with 2 element of B. That is not possible in function. We have to associate with unique, it means only one element of B. Okay, so C can't be associated with 2 value of B. Okay, so this is also not a function. Remember, actually these are value of x and these are value of y. For any x you can get only one y. Okay na? There is no option like this one, either this one or this one. Okay, any problem? Write down. Definition is clear na for function? Okay, can I? Okay. Pause and write down. Okay, after this one you can represent any function in terms of y equals to fx or ordered pair form or pictorial form. Okay, so I am taking representation of function. Now next topic is representation of function. First one, you can represent any function in form of y equals to fx form. Okay, like y equals to sin x, y equals to e power x, y equals to log x. Okay, these all are like y equals to fx form. Second, pictorial mapping form. Okay, by pictorial mapping, and actually we have to use this one in case of only when a and b are like set of natural number or integer or whole number, like this one. Okay na? So suppose I am taking a, this one, and b. In a we have a, b, c, d. A is a set of these elements and b 1, 2, 3, 4, 5. Suppose a is connected with 1, b with 2, c with 3 and d with 4. This is a function from a to b and you can write this one as a to b. This is the pictorial mapping of function, and obviously this one is satisfying the condition to become a function. Condition to become a function is each member of a must be associated with a unique member of b. It means you can't connect 1x to 2y, but you can connect more than 2x with 1y. Okay. Now see, in this one, these are the values of x, and in set b you will get values of y. If you write in terms of y equals to fx. Okay, these are x and these are y. Now again, like relation, we have something that's domain, range, okay, and codomain. Domain is actually values of x. Now see, this is the domain. Domain is equals to a. Okay na? Domain is equals to a. Always for any function, if function f from a to b, then a is always domain, values of x. Okay. Now range, values of y is range. So values of y is These are possible value of y na. Okay, 5 is not value of any x. So this is the range, and for this function range is equals to set of these element 1 2 3 4. Okay, and what about b? Actually this b is known as codomain. Okay, codomain is equals to b, and one thing, range is always subset of codomain. Okay na, this one is always subset of codomain b. Okay, now under this function this one is the value of a. So 1 is known as image of a and a is known as pre-image of 1. Okay, so this 1 is image of a under function f. Okay, and this a is known as pre-image of 1 under f. Okay, so if a is connected with 1, then 1 is image of a and a is pre-image of 1. Okay, so image, pre-image is clear, domain clear, range clear, codomain clear. Domain is always equals to a, range is all possible value of y, okay, and b is always codomain. Now suppose in this one, if you want to write this one in terms of y equals to fx, here value of the function fa means value of the function at a. At a value of function is 1. Similarly fb value of function at b is 2. fc is equals to 3 and fd is equals to 4. Okay, and last form to represent a function, that is set of ordered pair. Set of ordered pair. Again, if you are writing this one, you can write this function in terms of set of ordered pair. I am just writing. Okay, so a comma 1, x comma y. Okay na, b comma 2, c comma 3 and d comma 4. Okay, this is the in ordered pair form. Okay, so this is clear. After this one I have a note, see, and that is important. So if any function is given in this form, then you can identify by checking that each element of a must be associated with a unique element of b. But suppose if graph is given, then also we have to identify na that graph represent a function or not. Okay, so what is the condition? Condition is simple. Okay, I am writing first, then I will explain. If any vertical line cuts the graph at more than 1 point. Okay, if any vertical line cuts the graph at more than 1 point, then graph does not represent a function. Okay, this is the only condition. Okay, I will explain that how we are getting. So I am taking a graph, sorry, two graph. Suppose this is any first graph, x axis, this one is y axis, and another one is a parabola I am taking, suppose this one. Now I want to check that which one is which graph represent function and which one is not a function. Actually, if you take any vertical line for this graph, then we are getting only 1 point of intersection. Okay, it means you can't draw any vertical line which intersect this one at more than 1 point. No? Okay, if you can't draw, it means if any vertical line can't intersect this one at more than 1 point, then this represent a function. This one is a function. Okay, how I can say? Because suppose na, at this point I have only 1 point of intersection. It means for this value of x, we have only one y. Actually, these are values of y na. This graph has values of y. Okay. Condition to become a function is for every x we have unique y, then this represent a function. If you have more than one y, then this can't represent a function. This is the condition. Okay. But in this case, I can draw a line which intersect the graph at more than one point. Okay. If intersect the graph at more than one point, then I can say that for this value of x, I have two values of y. Okay, if you have two values of y, it means one x is connected with two y. That is not possible in function. Okay, na? So I can say that this one is not a function. Okay, so any vertical line if cut the graph at more than one point, then this doesn't represent a function. If you can't draw any vertical line which cut the graph at more than one point, then this one is function. Okay, na? Okay, so write down. Okay, so if I repeat this theory, then function is basically a rule from a non-empty set A to another non-empty set B that associate each member of A to a unique member of B. Okay, just simply remember one thing, that each member must be associated. You can associate more than one x to single y, but you can't associate one x with two y. Okay, that is not possible. Okay, na? For example, y equals to sine x is a function. If you are putting x equals to 0, then always you will get sine 0 equals to 0. It is not possible that one day you are getting 0 and other day you are getting 1. Okay, na? Because that is function. So, I can have na, just pause and write down. Okay. Okay, now I am taking some example based on graph to identify that this one represent a function or not. Okay, so see, write a question. Which of the following is our functions? First one, y equals to root x. Second one, y square equals to x. Third one, y equals to sine x. And fourth one, y equals to 1 plus mod x. Okay, this one. Now see, first one, y equals to root x. Can you draw the graph of this one? Obviously, I can draw. See, root x this one. Now check by using the graphical condition. Can you draw any line which cut this graph at more than one point? Any vertical line, not horizontal. Okay, na? So if you draw any vertical line, then we are getting only one point of intersection. So this one is function. Okay. Second one, y square equals to x. Y square equals to x is a parabola. Power of one variable is 2, power of other variable is 1, then graph represent parabola. Okay, so parabola, power of x is 1, it means open toward x axis, positive x axis. This one na, y square equals to x. Okay, now I can draw a line which intersect the graph at 2 point, more than 1 point. So this is not a function. Okay. Third one, y equals to sine x. This is the graph of sine x. Okay. Now again, if you draw any vertical line, you will get only one point of intersection. Only one point of intersection, then this also represent a function. Okay. And fourth one, finally, y equals to 1 plus mod x. Okay. Now if you draw the graph, mod x is this one, na? This one is mod x, but here you mod x plus 1. This is the mod x plus 1. It means shift the graph 1 unit. Okay, na? Above, because we are adding 1 in mod x. So what you will get? Like this one. Shape remains same, only just shift the graph 1 unit. And this one is 0, 1. Obviously, if you put x equals to 0, then we are getting 1 plus 0, that is 1. Okay na? Again, if you draw any vertical line, then you will get only one point of intersection. So this one is also a function. Okay, so graphically simply we can check if any vertical line cut the graph at more than one point, this can't represent a function. If intersect only at one point, then these all are function. Okay, write down. Okay na? Okay, now next. Okay, so up to this one we have only 2 points we have to remember. First one is condition to become a function, that each element of A must be related with associated with a unique element of B. This is the definition of function. And if graph is given, then we have to check by taking any vertical line. If any vertical line can intersect at more than one point, then graph does not represent a function. Okay, after this one what we have? Function done, representation done, graphical condition done, then domain and range of the function. Okay, domain and range of function. Okay, now actually this one is similar. I have definition also, but there is no need to write. Okay, easily we will get many questions based on this one, so you can remember. But also we have one thing now. If there is a function from A to B, then A is domain. Values of y in B known as range. Okay, na, set of these values, and B is known as codomain. Okay, but this is I am taking when only y equals to fx is given and we want to find the domain and range. Then how to find? If only expression y equals to fx is given, if only expression y equals to fx is given, then domain is the set of all possible values of x for which fx belongs to real. Okay, for which fx is real, and range is the set of all values that y takes. Okay, or simply just remember one thing, all possible value of x is known as domain, all possible value of y is known as range. Okay, and one thing that we have to remember, if we domain and range both are subset of R, then function is known as real function. Okay, so if it is given that any given function is a real function, it means domain and range both are subset of R. It means both are real. Okay. Okay, write down this one, then we will take some example. Okay. Okay. Okay, so I am taking first question. Y equals to x plus 2, and this one is defined from W to N, whole number to natural number. Draw its mapping diagram and find its domain and range. Okay. So see, y equals to x plus 2, this is given as a function from w to n. Okay, I want to draw this one mapping diagram, this one w and n. Okay, w is set of whole number, so 0, 1, 2, 3, 4 like up to infinity, and this one is the set of natural number 1, 2, 3, 4 like this one. Okay, here I have 5, and now y equals to x plus 2, so we want to connect these. This is the function y equals to fx, or suppose y. Okay, suppose f is the function. Now if you put x equals to 0, what we are getting? Y equals to 2. These each value must be associated now. So if you put x equals to 0, then 0 plus 2, so 0 is connected with 2. If you put x equals to 1, then what we are getting? 3. If you put x equals to 2, then 4. If you put x equals to 3, then 5. Okay, so this is the pictorial mapping. Now what you want? Domain and range. So domain is always, this one is the domain. Obviously now values of x, each member is associated, each member is connected, it means these all x are in domain. So domain is always equals to this one for a function, okay na, a. And range is equal to set of all possible value of y, all possible value of y. So what we are getting? 2, 3, you can't take 1 now, 1 didn't have any pre-image, so 2, 3, 4, 5 like this one. And also you can write this one as n minus 1. Okay now, these all natural numbers are in range other than 1, okay, excluding 1, so I am excluding 1. Okay, this one write down. Okay, 1 minute. Next question, then y equal to x square, and this is from I to n. Okay, comment whether it is a function or not. Okay, now identify that this one is a function or not. Okay, if this one is not function, then relation. Okay, okay, now it is. Now identify function or not. Okay, condition to become a function is each element of A associated with a unique element of B. Okay, remember that if you want to say no, you want only one example. Okay, so see, this is from I to n. It means if I put any value from I at the place of x, then y must be belongs to n. Okay, now y must be in n. Na? So in integer I have 0. Okay, integer is minus infinity plus infinity, all integer. Na? If you put I belongs to 0, okay, sorry, 0 belongs to I. So if you put 0 at here, then value of y is 0. But 0 is not in n. It means in I we have one x, that is 0, which has no image in this n, okay, which has no y, then this can't represent a function, because each x must associated with a unique y. For x equals to 0, y is equals to 0, but 0 is not belongs to n. So this is not a function. Okay, 0 belongs to I. Here 0 is belongs to I, so I can check now. If you take anything other than 0, 1, then 1 is square 1, that is in n. If you take minus 1, then minus 1 is square is plus 1, again in n. If you take 2, then 4 in n, minus 2, 4 in n. Okay, other than 0, all has unique element in B. Okay, but to say no, we want only one example. If you have any one x which has no y, then also you can say that this can't be represent a function. Okay, this is not a function. Write down. 90% you will get question based on domain and range. Okay, not these type. Now this is only to understand the theory. Okay, in next lecture we will take only domain and range question. Okay, it will take 2 lecture for domain and range, na, for complete. Okay, because that is always important, na. Okay, so can I write this one? Okay. Okay, 1 minute. Now can you find? Okay, I am taking a question from my side. Let n of a equals to 3 and n of b is equals to 2. Okay, then find number of relation and function from A to B. Okay, number of element in A is equals to 3 and number of element in B equals to 2. Now we want total number of relation and function, okay, from A to B. Remember that all relation are not function, but all function are relation also, if element are given in this one. Okay, so how to identify? Okay, first for relation, total number of relation. Relation is subset of A cross B. Okay, every subset of A cross B is a relation from A to B. So first you have to find the number of element in A cross B. Okay, and obviously I have direct formula. If A has 3 element, B has 2 element, then A cross B has 6 element, 3 into 2. If A cross B has 6 element, then number of subset of A cross B is 2 power 6. Okay, 2 power 6, and these all subset are known as relation. So total number of relation is 2 power PQ. If you remember the formula, then 3 into 2, 2 power 6, that is equals to 64. So total number of relation from A to B is 64. Now total number of function. Okay, now actually to get a function, suppose I am taking this one in pictorial form to understand or to explain this one. In A we have 3 elements, suppose A1, A2, A3. In B we have 2 elements, B1, B2. Okay, now we want total number of function. To get a function, I have to satisfy the condition. Condition to become a function is each element of A must be related to unique element of B. Okay, so you have to connect each element of A to a unique B. First consider A1. Okay, you are connecting A1 now. For A1 how many options we have? We have 2 options. Either you can connect A1 with B1 or B2. Okay, suppose this one. So for A1 I have 2 options. Okay, now for A2, again you can connect A2 with B1 or B2. For A2 also you have 2 options. So again 2. Now for A3, again I can connect A3 with B1 or with B2. So again I have 2 options. Remember that you can connect A1 with anyone out of these 2, but you can't connect with both simultaneously. Okay na? So for A1 we have these 2 options. For A2 again we have these 2 options. For A3 again we have these 2 options. Okay, so total is 2 power 3, that is 8. Okay, so actually total number of relation from A to B is equals to 64. Out of these 64 relation, 8 relations are become function. Okay, any problem? Not now. Okay, okay, done now. Okay. Okay. Now next, okay, I am taking a simple one. Next question, find domain of the functions. First one, y equals to root x minus 3 whole square 2 minus x and x square plus 3x plus 2 and divide by x square plus 5x plus 30 into x plus 1. Okay, now you want domain for this one. Now domain is all possible value of x for this function is real. Okay, so what is the condition? Here we have y equals to this one. Here we have root, and we know that root is only defined for positive values. Okay, or 0, no negative values. Okay, na? So to define this function, this value must be greater than equals to 0. If this one is negative, then root is not real. Okay, na? Then it become imaginary. Condition to get domain is all possible value of x for which function become real. It means this become real, so this one must be greater than equals to 0. Apply the condition. So x minus 3 whole square 2 minus x square plus 3x plus 2 by x square plus 5x plus 30 into x plus 1. This one must be greater than equals to 0. Okay, now see, I am rearranging this one, x minus 3 whole square. Now we want all possible value of x. I am taking minus common, then this become x minus 2. Why I am taking common minus? Because to follow the to arrange this one so that I can use the rule of sign scheme na. Okay, so coefficient of x must be positive. Factorization x plus 1 x plus 2. Okay, here we have one negative sign. I am multiplying this one at this side, so I have to change the sign. Okay, 0. In division what we have? In division we have x. Now actually you can't factorize this one. Okay, na? Because for this one d is, find d, b square minus 4ac, 25 minus 120. Okay, na? D is negative. If d is negative, it means no root, so you can't factorize this one. Okay, x square plus 5x plus 30 as it is and x plus 1. Now see one thing, I can simplify this one. I can cancel out x plus 1 to x plus 1. But now remember, in next step you are getting x minus 3 whole square, x minus 2 and x plus 2. In denominator we have x, and also one thing, if you are cancelling these two, okay, then there is no x plus 1, but you can take any value of x such that denominator becomes 0. Actually this x plus 1 is given already, so you can't put x equals to minus 1. If you put x equals to minus 1, then this becomes 0, this becomes 0, then total become infinity, and y can't take infinity. Infinity is not in R na, open interval we have at infinity. So here I have to write, if you are cancelling any factor, then remember that you can't take any value of x such that for given function is become infinity. Okay, you can't take minus 1. So here I have to write that x can't be equals to minus 1. Okay, here we have x square plus 5x plus 30 less than equals to 0. Okay, now use sign scheme to find the value of x. If you put this one equals to 0, what we are getting 3, from this one 2 minus 2 0. If you put this one equals to 0, you will not get any value of x. Okay, so indicate them on number line. So 3, 2, minus 2 and 0. So list is minus 2, then 0, then 2 and then 3. Now you can use the sign scheme. Okay, minus infinity to plus infinity. Okay, so see, all coefficient of x is positive. Okay, there is no negative sign. Then at the right side we have to put plus. Now 3 because of this one, because of this vector, and power is even. If power is even, then it doesn't change the sign, sign remains same. 2 because of this one, power is odd, 1 is odd now. If power is odd, then change the sign. 0 because of this one. Okay, power is odd, then change the sign. Okay, minus 2 because of this one, power is 1, odd, then change the sign. Okay, if power is odd, then change the sign. If power is even, then you can't change the sign. Okay, and also you have another method to decide these sign. Okay, so actually now this is the process that in this interval, after dividing in interval, always this is definitely confirmed that in this interval you have only one side, either this value become positive in this one or negative, but can't take both. Okay, so just put any value between 3 and infinity. Suppose I am putting 5. If you put 5 lies in this one na? Okay, so just find for 5. If you put 5, then this one is positive, 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 positive. If all are positive, then complete is positive, positive sign. Suppose if you want sign between 0 and 2, then any value between 0 and 2 is suppose 1. Put 1. If you put 1, then this one is always positive because of square. 1 minus 2, negative. This one is positive, negative, positive, positive, positive. So all are positive other than this one. This one is negative. One negative, all other positive, then total become negative. Okay, like this one. And what we now we want the value of x. Here we have less than equals to 0. Okay, less than equals to 0. So I have to take interval with a negative sign. Okay, so I am taking with a negative sign. So see, minus infinity to, so x belongs to minus infinity to minus 2. Minus infinity to, remember you can't take minus 1. Okay, can I include minus 2? Here we have equals to, and minus 2 because of this one. If you put minus 2, then this becomes 0. 0 is less than equals to 0, satisfying, so I can take. Then minus 2 to 0, you can't take. Then 0 to 2. Okay. Union 0 to 2. Now check one thing, that can I take 0? Actually, if you take 0, here we have equals to, but if you take 0, then this becomes denominator. You can't take any value of x, sorry, this becomes 0. You can't take any value of x, for that denominator becomes 0. So I can't include 0. Now 2, can I include 2? If you put 2, then this becomes 0, then total is 0, 0 less than equals to 0. Okay, satisfying. After that, you can't take this interval, also you can't take this one. But 1 minute, I have to decide for these na, 3. Up to this one is decided. 3 can you take? Check. If you put 3, then this becomes 0. Total is 0, less than equals to 0, satisfying now. So union 3. Okay. Actually, at these points, this value is either 0 or infinity. If infinity at that point, then you can't take, but if 0, then we can take now, because here we have less than equals to 0. Okay, so this is the domain for this one. Okay. Okay, now we will take a remaining question in next lecture. Okay, revise this one.